Greetings to the panel ahead. We are here representing Group 12 and we are all from the branch ENC. We are here to present our work on the topic Image Guard and I am Arnavjit Sodhi.
I am Alisha.
I am Kudratnoor Singh.
And I am Aastha.
In this project, we are discussing all the passive approaches of image forgery.
So on the screen, you can see on the left part is our code for copy move forgery detection, and on the right hand is the flowchart for the same. First, user will provide the input image. After that, in the backend, we have used this algorithm in which in the first step, first image will be converted to grayscale, and then grayscale image will be divided into blocks. Basically, we have used this block technique so that we can have better detailed analysis. After that, we will apply DCT on each block and then zigzag scan will be applied. In the next step, we will perform the lexicographically sorting so that we can have groups of the similar feature vectors. After that, it is a deciding factor. So if lexicographically sorting is performed enough, then we will move forward, else we will again perform the lexicographically sorting. For feature matching, we have used Euclidean geometry, which will actually calculate the Euclidean distance between two features. Smaller Euclidean distance suggests greater similarity. In the last, we will remove the isolated block and the output image will be displayed on the screen. You can see on the left side is the input image and the output image. On the screen, you can see the image retouching code on the left hand, and on the right side is a flowchart for the same. In this also, the user will upload the input image. Then Gaussian blur is applied on that input image because the contrast of the input image can be high in retouching case. So to counter that, we will apply the Gaussian blur. In the next step, we will compute the Then we will compute the absolute difference between the two images and convert the difference image to the grayscale. Then we will apply the threshold and compute the retouching score. This retouching score is a deciding factor in our algorithm. If the retouching score is greater than the sensitivity threshold, then we will say that the image is forged, and if it is less than the sensitivity threshold, then we will say that image is authentic. So this is the flowchart for the image retouching part that we have used, and on the left hand you can see all the outputs of the steps.
On the right is the methodology used to detect spliced images. To train the model, we have used the Cassia dataset, which contain authenticate and spliced images. If the images are in grayscale, converted to RGBA. We have to compute the ELA intensity of the image. ELA is error level analysis, in which difference between authenticate and spliced images are computed. Here you can see some sample images also in which we have calculated the ELA. In the next step, we have labeled the data set. We have also used image data generator for the better training of our model. I'll show you the code for the CNN model that we have made. This is our model. We have saved this model and here we provide the path from image path from the website. We will perform the computation on this image, and we will check if the image is spliced or not. So the motivation behind this project is to find the marks of tempering in images is becoming challenging. It is being used for hiding facts and evidences. Facility of manipulating the image is being provided by many apps nowadays. Our website provides facility to tell whether the image provided is authentic or tampered with. Thank you.